Hello children, welcome to Wandicom. In this video, I'll explain the valency of an atom or an element, valency, in a little elaborate way because I have already explained the preliminary concept and the definition of this valency in one of my previous video, that is the part 1 of valency. So if you have not watched that video, please find the link from my description box here. So before going for the details of this valency, one should know the arrangement of electrons in different orbits or cells of atom in elements, and the filling of these electrons is governed by Bohr-Bury scheme. And according to this scheme, there are certain rules for filling of these electrons in the cells, and the first one is the maximum number of electrons that can be present or accommodated in a shell is equal to 2n square. That means is follow this rule where n is equal to the orbit number or the serial number of the shell from the nucleus. That is this is 1 2 3. If you this is nucleus, then this is the first orbit, or n is equal to 1. This is the second orbit, or n is equal to 2, and so on. This is your 3, and we generally call it as KLM. So as per this rule, when n is equal to 1, then your as per 2n square, it will become this square or 2. So total 2 electrons can be present or accommodated in the first cell. Similarly, when n is equal to 2, then your as per this 2n square, it becomes 8. So total number of electrons that can be, maximum number of electrons that can be accommodated in the second shell or orbit is 8. Similarly, we can go for this third and fourth orbit. And as per the second this rule, this one, the outermost cell cannot have more than 8 electrons, and the penultimate cell cannot have more than 18 electrons. So this is the outermost, and the cell which is just inner or just before the outermost cell is known as penultimate cell. Penultimate cell, and this is the outermost cell. Outermost cell or the valence cell. And the third point is electrons cannot be or cannot enter into a cell until the inner cells are filled. This means that the cells are filled in a stepwise manner. First, if once the first orbit is filled, or the cell is filled, then the electrons will go to the second orbit, and then once it is filled, second orbit, then it will go to the electron will go to the third orbit or cell. So here I am showing the arrangement of electrons. So you can see in this picture the elements are arranged from atomic number 1 to 18. This is not actually the periodic table, but extract of the periodic table, and it is arranged in that way. So you can see here, and the hydrogen with atomic number 1 has only one electron, so it goes to the first cell or the K cell. Similarly, helium with atomic number 2, so the electrons are or the two electrons are going to the same cell. In that left hand side you can see the number of cell 1, 2, 3 has been given. In case of lithium, its atomic number is 3, so the third electron is going to the second orbit, or n is equal to 2, and likewise it will go from lithium to your neon with the atomic number 10. So the second orbit is filled up with 8 number of electrons, and then comes to sodium with the atomic number 11. So the 11th electrons will go to third cell, or the L or N is equal to 3. So likewise that sodium, magnesium, aluminium up to your argon. So this is the arrangement of electrons in the first 18 elements of the periodic table. Again, as per your Bohr-Bury scheme, maximum 8 electrons can be accommodated in the outermost cell of an atom to get the stable electronic configuration. So there is always a tendency for the atoms to get the 8 electrons in their valence cell, either by losing electrons or by gaining electrons. So the atoms of the elements with 1 electron or 2 electrons or 3 electrons in their valence cell can lose this 1 electron or 2 electrons or 3 electrons to attain this stable electronic configuration. For an example, in case of sodium, with atomic number 11, the arrangement is 2, 8 and 1. So 1 electron is there in its valence cell. So by losing this 1 electron, it becomes 2 and 8. So this is a stable electronic configuration, and by losing 1 electron, it becomes Na plus. So that means it has the valency of sodium is 1. So similarly, in case of magnesium, this is 12. Its atomic number is 12. So 2, 8, 2. So in its valence cell, 2 electrons are there. So by losing 2 electrons or 2 electron, it becomes stable. So it becomes 2 and 8 electrons in the outermost cell. So the magnesium becomes 2 plus 2 electrons by losing 2 electrons. So its valency is 2. Similarly, in case of aluminium is 13. Its atomic number is 13. So arrangement is 2, 8 and 3. So outermost cell, 3 electrons are there. So it has the tendency to lose 3 electrons to get the stable electronic configuration. So and this becomes your Al3 plus. So by losing 3 electrons, it becomes the ion aluminium 3 plus. So its valency is 3. So the atoms which are losing the electrons to becomes this ion, positive ions like sodium or magnesium or potassium or aluminium, they are the metals. Similarly, the atoms of elements with 5 electrons or 6 electrons or 7 electrons in their valence cells or the outermost cells have the tendency to accept electrons to get or attain the stable electronic configuration. That means those atoms which have 5 electrons in its valence shell will accept 3 more electrons, and this accept 2 more electrons, and in such case it accept 1 electrons to get stable electronic configuration in their outermost valence shell. This happens in case of your nitrogen, and this happens in case of oxygen. And chlorine is having 7 electron in its valence shell, so it accepts 1 electron and becomes a stable electron to get the stable electronic configuration. Similarly, oxygen accepts 2 electrons, nitrogen accepts 3 more electrons to get stable electronic configuration. So by accepting 3 electrons, the nitrogen becomes your 3 minus, or oxygen becomes 2 minus, or chlorine becomes your 1 minus 1. Okay, so it has the valency 3, oxygen has the valency 2, and chlorine has the valency 1. In that way the valency are decided, and these seems to be the non-metals. Just have a look in this chart. The elements of group 1, 2, 3 are metals, whereas the elements of group 5, 6, 7 are non-metal. In group 4, carbon is non-metal, whereas silicon is metalloid. Elements present in group 8, such as your helium, neon, argon, have completely filled valence shell and are less reactive, and their valencies are 0. So we came to know that there is a tendency of an atom to achieve 8 electrons in their valence shell or the outermost shell, and this tendency is known as your octet configuration. And this octet configuration can be obtained not only by losing or gaining, but also sharing of electrons with another atoms of same or other element. And the number of electrons gained or lost or even shared in this process is the combining capacity or the holding capacity, or simply we know that this is the valency of an element. Besides, some elements show more than one valency, which is known as your variable valency. In such case, the atoms of an element can lose more electrons along with the valence electrons. That means this electrons loss is from the penultimate cell. So metals like iron, copper, lead or tin, and non-metals like your nitrogen, phosphorus, sulfur show this variable valencies. Hope you have understood the concept. Please give your comments and feedback. Thanks for watching.